There we go. All right, here we go. First, thanks so much for the invitation to speak with you today. I think we're almost all here, and it's really a pleasure. So we're going to be talking about machines reading maps, which was originally funded by the New Directions for Digital Scholarship grants that were made available from the NEH and the AHRC. So as you can see, we're a team that spreads across the US and the UK. At the University of Minnesota and University of Southern California in the US, and then at the Turing and the Austrian Institute of Technology in the UK and obviously Austria. In addition to that, we have three cultural heritage partners: the National Library of Scotland, the British Library, and the Library of Congress. And I think maybe with the exception of the NLS, there are representatives from those institutions here today, so that's really exciting. We're really honored to be working with their map collections, their digitized map collections, and I'll say some more about that in just a moment. So just first, the kind of most obvious question of why we're doing this work is, why is text on maps interesting? So machines reading maps' ultimate goal is to really figure out how to make text on maps usable metadata and data. Text on maps is interesting both in terms of making maps more discoverable in library and other collections. And it's also really incredible, an incredible resource, potential resource of research data that can really transform the way that researchers across disciplines and indeed the public can interact with maps as they're being digitized around the world. And so I just want to give you an example of one of the collections that we're working with is the Ordnance Survey maps. This is a kind of very, very zoomed in sort of example from Coventry. This is a 19th century sheet printed by the Ordnance Survey for Coventry. You can see Coventry is a city of bicycle factories and metalworking and previously watchmaking. So it's a very interesting place to look at the development of industrial and kind of commercial sites related to those industries. And as you can see, the text gives us a lot of clues about the kind of spatial nature of the industrial period. So this is one of the things that really kind of emerged as a research question on the other project that I'm involved in, which is Living with Machines, also a Turing-based project, where we wanted to really figure out how to work with maps at scale. And as I was looking into that, I was lucky to connect with Yao Yi, and that project grew out of early conversations about his longstanding work in the field of historical map processing and figuring out how to make this data that's presented on maps usable as geospatial structured research data. So I'm going to turn it over now to Yao Yi, I think, who in turn will turn it over to various other people. So there we go.
Thank you, Katie. So like Katie said, we are working on historical maps, and these are historical map scans. And our ultimate goal is to be able to extract information from these maps. So the extracted information, we want to also organize them in a way that's easy for the end user to search and support complex queries. So that means we are provide some semantics of the metadata. It could be from a user-defined ontology, it could be from commonly used standards. This is together with machine and human, as you might see in the title. That means we want to have the machine learning algorithms to do most of the tasks, but it has to work with a human, but with as little user effort as possible, since there are just too many maps. We are looking at thousands maps. So here to show you a short book we published 2 years ago on all these different case studies on maps and our recent advances in machine learning algorithms to extract features from maps and also other related work. Can you go to the next slide, please? Yeah, so for specifically for text labels, we were at first looking at tools, OCR tools that would be able to just do recognition of text from images. So you might already use Google Vision API, Google Lens that will be able to read text from maps. But these tools usually would just give us all the separate words. For example, if you look at this map, Fall River is a place name or a place phrase, like we call it. But OCR tools doesn't really care. It will just give you 2 words. So this is not really what we want or generating metadata. Next slide, please. Also, there are crowdsourcing tools. These are this tool Rekajito is developed on the Bellagio Common, and Rainer and Valeria has been the main developer and community organizer for this tool. And this is an online platform that help organizing collaborative annotation on documents and also for maps in this case. And user can upload their data set, or the tool can connect to other data sources, image sources to download the data, and the user will start to provide annotations. It will be bounding boxes, name of the label, and link to an external data set. Next, please. So here I'm going to tell you about what we have right now. On the left side, you can see these are scanned map images from various sources. Some of them have metadata, but most of them are just images. And we can retrieve all these maps from different types of services like IIIF, WMTS, that's web mapping services, or it would be a standalone GeoTIFF or TIFF images, JPEG files. And in our current process, the entire system will take the input map and either go up for that searchable part, that's automatic annotation, that's a machine learning algorithm that will automatically detect and recognize text labels, send it to Map Curator, that's another machine learning model to group related words together to generate place phrases, like group Los Angeles into Los Angeles, and link this place phrase to an external knowledge base. What we're using right now is Link Geodata, which is a version of OpenStreetMaps. And at the bottom, that red box, that's Rekajito. So the user will have the opportunity to edit and correct machine-generated text, or the user can add more text that the one that machine did not correctly identified. And the overall goal is to be able to use this pipeline and generate some gold standard data set on the bottom right. We call it gold standard, but we also understand that gold standard is not really a thing, because different people, different community might have their own gold standard. So this is to show you that anyone would be able to use the entire pipeline to generate their own gold standard data set. Next, please. Oh, okay. So yeah, that's just we took all our previously developed tools and put them all together.
You want to hand it over to Rainer for this one?
Yeah, I can say this. Yeah, so basically we modified the existing platform, which has been around for a while, for the project specifically, and created an interface that worked more closely to the requirements of the project. We also added a bit of more solid support for IIIF, so that's of course important in this context, but also added support for WMTS served maps. So the customized version of Recogito is now fully able to work with geo-referenced materials, so that's a nice bonus that we added. It has better support for linked open data sets. So semantic type tagging is an important part of the project. So it's not about just transcribing, but also mapping labels to the semantic types that they represent. So there's been some extra work on that. Yeah, I would say that's it. I think in the end, maybe I can say a bit more about the technical bits behind it, but otherwise I would hand back to Yi, I think. There's a few feature previews. Yeah, we added other features like grouping, for example, so you can now create groups of annotations, which wasn't possible in the original tool. That's important specifically for labels where, well, it's important for associating labels with things like building footprints on the one hand, but it's also important for working with labels that are spread across multiple words. So if you have like a road label that's stretched across across a wider distance, you might want to annotate words individually, but still you want to group them and you want to give them an order. Next slide. I haven't seen those slides before. Let's see what comes next.
I can do this one.
Okay.
Yeah, so this is just to kind of, it's another version of the kind of slide that Yaoyi showed earlier to walk you through sort of the relationship between the automatic identification of text that we're developing, the tools that Yaoyi was just describing, with the manual annotation of text and some sort of tags and gazetteer links that we're using Recogito for. And really how these work hand in hand. As Yaoyi was mentioning, we use Recogito to allow us to create the gold standard for some particular case studies that we're working on with ordnance survey maps and with Sanborn maps from the Library of Congress, and some GODE maps from the National Library of Scotland and a few other smaller corpora, as well as now the Rumsey maps. But the really exciting thing that we'll get to when we're talking about the Rumsey project is the way that Recogito is also becoming a site for a kind of crowdsourced validation or editing of the data that comes out of Map Curator, which may need to be corrected and then eventually fed back in as training data. And I just wanted to say quickly that we're able to roll out this version of Recogito not just for our own kind of internal team use in workshops and other people who might be wanting to create manual annotations or edit Map Curator output on their own map corpora, but it's also being used as a platform for crowdsourcing the collection of text on ordnance survey sheets of the 25-inch 19th century sheets of Edinburgh. So this is a collaboration with Chris Fleet and his colleagues in the Maps department at the National Library of Scotland that will go live in May, I believe. All right, so I'm going to turn it back over to Yaoyi.
So here we are showing our machine learning pipeline. Just to get you under a bit more information about how we pass information in this map curator model. So the input is a map image. Text detection recognition is a machine learning model to detect text, recognize them. And we have a synthetic map generation model that I'm going to talk about later. Then we can generate location phrases. And you can see in the middle, those are place phrases or location phrases. We can then use them to geolocate the map. Now we have more metadata for the map because originally the input is just a scan image. We can take all this information, query an external data set, then perform the linking. Next slide, please. So for location phrase extraction, you can see here on the left side, originally these are from Google Vision API, so it's single words. And we have a machine learning model to detect textual. It's called the textual model because it's using the context of the text and capitalization and other information to try to see if we can group them together. And this model has high recall and low precision, which means if the two words are in the same phrase, most likely it will group them, but with lots of errors. So the next model in the pipeline is a visual model. It says, okay, if you are labeling the same feature, that means you are surrounded or you are nearby some similar features. Could be a river, blue lines. So this visual feature has a really nice characteristics. It has low recall, but really high precision. So it helps us to refine the result from the textual model. So on the right side, you can see that the two detected and recognized words now is grouped together into one location phrase. Next, please. Oh, so here's the synthetic map generation. if you ever use a machine learning model, you will know that we need a lot of human annotations. You need to show the model lots of text symbols on various kinds of background, but we don't really have the resource to annotate them. So this shows you really interesting work we did recently. Here you can see this is OpenStreetMap, which means we can get the data in vector format. We can edit the data. We can look at the text. It's all machine readable. So we take this data, we build a machine learning model to generate historical map styles from this data. And this is ordnance survey style. And when you look at this map, it looks like historical maps, but all the content are directly from OpenStreetMap data. And because we generate them, so we know the location of the text, we know the location of the feature, and we can use this to train a text detection and recognition model. And also we did use this synthetic map to improve the accuracy of current text detection and recognition model. Next, please. Okay, so we are in our first month working with the David Rumsey Historical Map Collection. Our goal is to be able to use our automatic pipeline first to process all the 60,000 georeference map in the Ramsey collection. And we want to be able to figure out how we can use this opportunity to make sure that we understand how machine would better work with maps to generate rich metadata from all these historical maps. So this also includes customizing Rekajito to enable crowdsource editing of the machine-generated results or adding more annotation results. Next, please. So here are some results from the David Rumsey Map Collection by just running our machine learning model. So on the left side, you can see this is printed text and pretty straightforward. These are all horizontal text and we can do it pretty well. On the right side, you see these are house numbers. We did it okay. Here are some places we need to improve the model so that we will be able to recognize individual numbers and large font. Next, please. And here also shows you maps with different font size and styles, complex background. This will show you how rich the map collection is and the challenges that the machine learning model has to deal with, because many of the maps are not in the training data. And we're expecting that if we create more synthetic map of various styles, we should be able to improve the accuracy of the machine learning tool. So Katie, do you want to talk about the next one?
Yeah, sure. I'm just going to wrap up with saying kind of what our next steps are. So the first is to continue working with our initial partners, and specifically I mentioned the Sanborn maps from the Library of Congress. This is, I'm sure a lot of you know, a really, truly astounding collection of maps, very, very large scale urban maps of cities around the US. And indeed, we're exploring the way that fire insurance mapping is actually quite an international, a global phenomenon, and looking at collections of fire insurance and other very large scale mapping initiatives, urban mapping initiatives around the world. So that's a very, very kind of interesting work that we're pursuing next in terms of understanding how we capture text on maps, how we structure that information. It's very, very complex and intricate information that includes everything from the business name of a business occupying a building to the number of stories that building has, other measures of elevation, and there's lots of other kinds of information that goes beyond text, where one of our future steps is to really think about how we connect the text on maps to other kinds of information. So visual signals like the footprints of buildings, other kinds of symbology, as well as things like color. So those are really important next steps beyond the scope of our initial work, but this will feed into, we hope. We are currently testing Map Curator on the entire 60,000 maps that have been geo-referenced in the David Rumsey collection. So that's about a half of his total collection. And one of the real goals, as Yao Yi sort of showed, was that there's so much diversity in the Rumsey collection in terms of map style, temporal diversity, different cartographic cultures represented there, that we're really able to kind of push the limits of Map Curator and see where it functions well and where we need to kind of have either more training data or think about different kinds of machine learning functionalities that will help us get higher quality automatic results from Map Curator. Of course, Recogito is a really important component of that, and there's going to be I think Reiner's here, so if you have any questions about the work that's going to be going into integrating Recogito with Mirador, I'm sure he's happy to field those. We're also really excited about sort of thinking through the way that the crowd will interact with the data that's created by Map Curator. So the process that users, people who are excited to work with Rumsey's maps in this way will want to contribute to editing the output of Map Curator. So we're really excited to think about the nature of that workflow, how to make it as easy as possible for people to edit and improve that data, and really contribute to the process of making these methods work well on a wide variety of maps. So with that, I think I'll end unless anyone else has any final words. Yeah. Thank you. Thank you so much for your attention.
Yeah, thank you all so much. This was such a wonderful and interesting and amazing presentation. It's so cool to see the work that you're doing. Does anyone on the call have any questions for the team?
Hi, this is Kevin Dyke from Oklahoma State University. I had a question for the group. I had a chance to install the Docker image of Map Curator and feed it some of my digitized collection. Just as a little background, I have a collection of over 2,000 maps that show land ownership and values for every piece of rural land across the state of Oklahoma in 1936, and it's handwritten. And we're doing a crowdsourced, like, pure transcription right now of it. But so I tried out Map Curator, and it was able to sort of get that first step where it recognized a lot of the text and things. But in terms of the phrase, like the grouping, I'm guessing that that's where providing training data comes into play. So I just was wondering if you all are planning to provide any steps or just any sort of workflows more in depth about how we can add our own training data or things of that nature to adapt Map Curator for our own collections. Thank you.
Oh, that's a great question. We haven't thought about that yet, but yes, that's a great comment. We will do that. And we are submitting a workshop proposal to UCGIS this year in Syracuse. So if you are interested, please come join us. And if you request any new features like this, we are happy to talk to you and add it to our future plan. But we will definitely going to add this.
Yeah, I would just say also we're doing a lot on the project to think about, just this aspect of what it means to collect training data. So, we put a lot of time into thinking about how to create this bespoke Recogito platform that really lends itself to annotating maps. So anyone who's familiar with Recogito will see some of the things that have been tweaked. We're happy to share that with people so they can peek and have a look. And developing a really rich set of resources around the decisions and the thinking that's going through the process of our gold standards for our case studies. And Valeria might want to say some more about that if she wants. But this aspect of collecting training data is cool, but it's also just really, really amazing to see how much people value just being able to do manual annotations kind of quite easily. They don't even care about the machine learning aspect of what we're doing, but they find the kind of yeah, I mean, the attention that we're putting into figuring out how to create structured data, which can be used for research or for improving discovery in collections, really handy. And whether you scale that up and use that as training data or as a gold standard for evaluating the results of your algorithm is another question, in a sense. So that's been really exciting to hear people be enthusiastic about that.
Hi, this is Adam Cox. I had a question about, you mentioned your next steps were using the Sanborn maps in the Library of Congress. And I guess my question is, are you analyzing these maps after you've georeferenced them, or are you doing that before? And this is really closely connected to what I'm working on for my master's thesis. So I'm just curious to hear a little more about that.
Yeah, you should probably say something about what we're doing to kind of sort of rough georeference, so to speak. But really kindly, in order to assess that method, the Library of Congress, Paulette and Rachel Frank, Paulette Hazier and Rachel Frank, and those colleagues have georeferenced sort of, by hand traditionally in ArcGIS 100 sheets so that we can evaluate the results of the method that we're going to be using for georeferencing the collection, because yeah, it isn't georeferenced, and that's a big hurdle. I'll turn it over to Yaoyi.
Yeah, so it really depends on what kind of analysis we want to do. So what we are working on right now is to generate analysis ready data as much as possible, as accurate as possible. So basically you can think of from a scan image, it becomes layers in GIS so that people can do analysis. But for the analysis part, we haven't really thought about how we are going to do this. For Sanborn fire insurance maps, I think Deb here from USC Digital Library, we have some work with faculties that look at Chinatown, how it changed over time from in the Sanborn fire insurance maps in Los Angeles. And there could be other projects as well.
And Bunker Hill.
Yes.
Great, thank you. Yeah, I'm essentially have worked on a crowdsourcing platform for that, for Sanborn maps in Louisiana. So I think what I'll do is email a couple of you, because there's about 330 sheets so far that people have georeferenced. So I'll get in touch.
Okay, nice.
It might be useful. Yeah.
Yeah, that's really awesome. I think Valeria heard about your project at Geo4Lib, and we were really interested. So please do get in touch.
Sure, sounds great. Yeah, thank you for the presentation.
I don't know if we're doing a list of questions here. I just wanted to jump in. It's an amazing project. I've been following it for a while, so it's cool to see some demonstrations of it. Just in terms of a volunteer, we would love to run it on the approximately 100 volumes of Boston fire insurance atlases that we've fully both georeferenced and mosaicked into WMTS layers. But I'm actually curious, some of this relates to Adam's question. I'm curious what the possibilities are for thinking about exporting data in a manner that preserves both the sort of pixel space geometry of the original digitized master object, and also the coordinate real world geometry, if we do have georeferencing information. Both, thinking about the way that the geographic coordinates are useful, obviously, if we're going to use it later in a GIS application or doing spatial analysis with other geographic information, but then being able to come back to the original objects in either a digital collections interface, or especially thinking about IIIF, the sort of pixel geometry of a IIIF service. So I'm just curious how you guys are thinking about that, whether it's really like a one or the other, depending on whether a source image has already been warped or not, or if there are opportunities to kind of include like a both and geometry in that pipeline.
Yeah, I can answer that. So what we do is for all the image recognition work, it's in the image space. So the result will be pixel coordinates, and from that we take the control point pairs that people use for georeferencing the map and generate latitude, longitude, WGS84 for all these image coordinates. So they will both be preserved.
Cool. Cool. That's great to hear. Can't wait to try it out.
Yeah, I think it's also worth saying that, you know, there are so many collections that aren't geo-referenced, and yet we're excited to begin working with them. And I'm really interested in thinking about how we enable sort of collecting annotations now and being able to work with those annotations once a map is, you know, geo-referenced, so we can sort of spatialize the annotations that were, in a sense, that were collected before. So I think that's something that, you know, I'd love to kind of think about in specifically a IIIF context, among other things. Yeah. I see there's a question for Rainer in the chat. I don't know if Rainer, you want to say a few words about some of the cool new things you're planning.
So what's the question in the chat?
Oh, sorry. It says, are you planning on integrating any of the specialty functionality? Yeah, oh, sorry, it's moving in Anatorius, of course, right? So sort of move. Yeah, I'll let you.
So the project-specific interface we built for machines reading maps is based on Anatorius. So it's basically already there. It's all Anatorius plus some plugins, either standard plugins that exist for Anatorius or some that we've developed specifically for the project. So yeah, if there's something, it's coming from Nikki. Yeah, if you're interested in something specific, then definitely do get in touch. It's possible to use everything with Anatorius. And I think this is going to improve even more with the Ramsey collection collaboration, because this, of course, is also going to be a new interface. And I think it's going to be really interesting to try out to build an interface which is going to be much more simple, I think, than the one that we built for the project, because it's going to be directed more towards a public audience or like layperson friendly interface. And we are really only beginning to think about what that would look like. So again, it's going to be heavily customized, but again, all will be built on Anatorius and all is going to be open source, which is also one of the basic foundational principles of the development work with the Ramsey collection.
Hi guys, this is such a great project. I'm so excited to see all the stuff that you presented here and to see that it's even better than I thought it was. Yeah, there's a little thing in chat about the interactions with this and Britspan's all maps work, which is just like a hugely exciting area too. But I actually wanted to ask something a little more technical about how you're working with the Anatorius annotations before feeding them into these neural network models. Anatorius uses like a W3 annotation scheme, and I'm just sort of curious, like, what is the architecture that you're using for storing the W3 annotations? Are you finding it easy to pass those straight into your machine learning models and to write those out of there? And have you thought about using the IIIF content state API, or does W3 annotation scheme seem to work really well for this sort of workflow? Because I'm trying to steal from you guys as much as I can for a very different project.
Yeah, so the annotations are just purely stored as W3C annotations, either in the pixel space if you're dealing with IIIF images, or if it's WMTS images, we are storing it's all polygons basically, and all the corner coordinates of the polygons are in WGS 84 coordinates. I have to admit, I don't know, I hardly know anything about the IIIF content state API, so that's something I need to read up on, I think.
I don't know anything about it either. Josh just mentioned it to me once as a possibility for my thing.
Okay, yeah, but I'm interested to learn more. At the moment, the IIIF web and the web annotation format works pretty fine for us. But as we move more into like things like integrating with Mirador, I think this is probably going to become more of a topic, I think.
And where do you, or how do you store those, or the JSON annotations? Do you have a cloud service that you're using for that, or are you local enough that you can just sort of pass them as a bulk file around when you need to export them?
No, the stuff is all local. So Recogito, the old platform, has a custom backend where everything goes, and then we just export manually, basically.
There's Bert Sponswork has been getting a lot of love in the chat, and I just wanted to say a word about that. It's so phenomenal, and we've been trying to think about ways to work with him, both on Living with Machines and on this project, and we've kind of faltered a little bit, but we'll get there eventually. And I you know, we're clearly kind of working in the same space with the same goals, I think, along with lots of you. So it's really exciting to just, you know, keep the conversation going and keep building those links up as we go.
All right, any other questions or comments or thoughts?
I just see a request for the synthetic map paper. I think Zakun is here. If she can throw the link to her paper in the chat, maybe, or if you go to that NLS blog post link, I think the paper, there's a link to the paper in that I posted earlier. So yeah, cool.
All right. Thank you all so much for this presentation. It was really wonderful. We'll take the recording and put the link in the notes for anyone who, and I just see that the link to the paper was posted in the chat there. So for anyone who's looking. Again, we'll put the link to the recording in the notes for anyone who would like to share it or you know, watch a rerun or anything like that. And if everyone's okay with it, we'll put it on the YouTube channel as well for others who are not able to attend. So again, thanks so much to the presenters and to everyone for joining the call today and asking really great questions and just having a really great and productive conversation. So we hope to see you next month. At the end of the month, we'll have a community call looking at Zooniverse and their use of IIIF as an ingestion method. So thanks again, everyone, and see you soon.
Thank you, Meg. Thank you, everyone.
Bye.
Bye, thanks.